the New Jersey Transit PTC implementation. So what is humping around now? My phone is doing weird stuff. Is it reconnecting? Did it reconnect again? Was there another outage? Just let me know if that is so. At the moment I totally cannot see if there is anything happening or not. AJ is not coming. He's not saying a thing. You're there now. I can read it. Was there another interruption or am I going through straight now? There was another interruption. Okay, guys, then I will abort it because I want to have a stream that is consistent and in one piece and not cutting out every 15 minutes. I'm so sorry. I will be back soon and let's check it out on the page. What happened to the videos? If the videos are fragmented again, then probably we can't do anything today. There was another outage, AJ said, and what does the video producer tell me? Yeah. Okay. It says broadcasting for 1 minute and 29. I don't know. And before that 1 minute and 5. Well, if every 1 minute and 30 seconds the internet cuts out, then there is no fun in doing this. Okay, guys, I have to abort this. I'm sorry. Say hello to Vodafone for me. And maybe they can finish there. And Nakura still not live, sagt the app. I'm so sorry. Yeah, it does not work. It does not work at all. Thank you for subscribing, Nakura, if you can hear me. Well then, see you next time, the CD Radar. I hope the guys will finish their roadworks around our place with all the rain that is coming down. Probably it is creeping into the cables and it is cutting out every now and then. So not much fun in doing this. I've guessed Vodafone, says Akura. Well, classic Vodafone, says CD Radar. Well, that's it. That is how it is. I actually got a new router now running that costs me $7 more per month, and it is just the same old with the internet cutting out every now and then. So AJ, what do we do? Do we think we can run this now, or should we not do it? Should we give it one more try? And still not live, like the app. I would just keep talking for 1 minute more, and if we got the more or less stable thing. No, I don't think so. Okay, guys, I'm sorry. We cannot do this with this setup. Now it seems good, but you know how long it takes. I don't know. For me it's working now, but to know if it will work. I give it one more try. You guys tell me if there is another cutout, and then we will call it a day. Let's start the service, and until we get to the presentation, we are probably already deep in the service, and if it cuts out then again, then I have to repeat it. Custom weather in June and clear, because I wanted the let's just try. I hope I did not scare away anyone who wanted to join actually with that, again. We're starting at Dover. Does not really look like all the cars are at the platform. First car is not. I've closed everything except your stream on my PC, so I don't interfere with your stream. Well, I don't think that this is the problem, AG, but thank you nevertheless so much. Here is the safety systems, alerter, ATC, and ASES. What did we want to do? We want the headlights, we want the ditch lights, indie brake, automatic brake and hold, that holds the brake pipe pressure. What fills the brake pipe, gauge lights on dim is good. And the marker lights at the end. Did I forget anything? Well, we will see when we start again. If you're restarting and restarting, then sometimes you're prone to forget your stuff. Did I turn on all the markers? Because that is something that I cannot see, but it looks good. If I go into the OBS, 30 seconds to take off. That means we can initiate the door closing procedure, done by a conductor, not by the driver. Service train 6636 to Denville is the next station, and New York Penn is the station where we are finally headed to. And we go. We're starting with a limited clear. That translates to an approach limited in the cab signaling and the controlled speed of 45, because we still have to go across a switch. As I said in the try before. As soon as we're clear of the switch and all the interlockings, we can accelerate to 55. Then also the cab signaling aspect will improve to a high green, most probably. Like now. Let the train run its length. If in doubt, can never hurt. And then we can pull down a bit more juice from the overhead catenary in our ALP-46 locomotive, the American daughter of the German Baureihe 101. The screen here is actually really helpful. Gives you the brake pipe indication, the line voltage, and the braking power, respectively, the tractive power. Why it always shows you here a bit of dynamic braking effort on truck 1. It's hard to say. Also happens if you're running the consist from the cab car. If it is blue, then we're applying traction force. Limit will decrease to 50 at the end of this straight. Can use the dynamic brake with the combined power brake handle. That was the ASES beep that indicates that the countdown starts. Before we get to Denville, the line speed will increase to 60, but we will get a signal soon, approach limited, that slows us down to 45 again. Because Denville is in a 30 limit and they use the signaling to enforce this 30 limit traditionally, even from times before the ASES access system was in place and we had only the ATC coded or continuous cab signals with the automatic train control that can control cab speed limits but not civil speed limits. So now for a short while we could accelerate to 60 if we want to do that, but soon enough we will get, and we can already see it coming up, an approach limited, so we have to slow down to 45. I've put the brakes into suppression so that we don't get penalty brake. Here is the 30 limit looming already, and this limit will of course be enforced by the advanced speed enforcement system, the ASES or access system, but also by a signal that can show an approach aspect as at best, and this will translate to a yellow light with a 30 limit here. Signal is already coming up. Slowing down to 30 before we hit the signal. Then we only have to acknowledge.
The next station stop is Denville. When leaving the train, please watch the gap.
And we're running up for Denville. See, on the ADU we have a yellow indication for approach, limiting us to 30 here. On our circle of light, what is the term that New Jersey Transit is using in its PTC implementation plan?
This station stop is
And we're actually a
Denville.
bit early. But we're supposed to stop here and not a bit further on to make use of this elevated platform for our doors here. I don't know. But we're actually ran the stopping position for a bit. At least this car here can be accessed properly. Well, all in all, it's a nice touch that those cars here who are not aligned with the platform don't open the doors. That was not always so, if you think back of previous Trains and World versions. It's always an interesting solution here with the level crossing cutting through the stopping position of the train. By the way, here you can see another line of the New Jersey Transit universe coming in, the Montclair-Boontown line. I guess if we unlock that collectible, it will also show the Morristown line and not... No, it actually shows the whole network, right, doesn't it? Whereas for our train, if we didn't know it before, it tells us that it is the Morristown line here. So in case anyone wrote anything in the chat, I did not get a new message since AJ told me that she closed everything. I'm here listening, says Akara. I'm very happy and nothing was said, says AJ. And now we are actually stopping at Mount Tabor while going towards New York City, and watching, of course, is Akura. Beautiful. So happy that you're still with me. And you will see Mount Tabor is actually a weird stop for a train going towards New York City. It's also a very smallish stop for trains going towards Dover, but going to New York City it's really weird because there is no platform actually for the train to stop at. So we're still in the 30 limit, and this is enveloped with an approach aspect, even though the next signal is not actually red, most probably. Maybe it is, but it does not necessarily need to be red, even though for us to give us an approach aspect.
The next station stop is Mount Tabor. When leaving the train, please watch the gap.
Mount Tabor.
This station stop is Mount Tabor.
So,
between the train and the platform when boarding.
Which side do we open the doors now? Left or right? Right was... Maybe the wrong choice? Left? Left was the correct choice. So this is actually what we do here. And people have to more or less cross the tracks, as it seems. And Akura says, I don't have any US route beside the Long Island Railroad, so I'm interested to see Morristown Line. Oh yeah. It is definitely a beautiful route. And there are many beautiful American routes. Since you get the Morristown Line for the trains in World 6, every edition better than the free starter edition. It's definitely a route that should be nice to get. And CD Ready, it's just so funny to hear the word Tabor pronounced as Tabor. Yes. But this is how they do it. At least the announcement lady does it. Tabor. While stop to have the passengers to cross the rails. Yeah, that is really weird. So, careful. Until we get to Morris Plains, we will have a couple of limits coming in without the signals changing. You will see that the cap signal aspect will be green all over. We're now at the 50. It will drop to 40, rise to 60, drop to 50 again. And that was the weird sound for the ASES axis alarm that also gave us a short penalty brake. Not to be confused with the alarm sound that we get from the signaling system. They're making us to 40 here now. And Akura says, no, I'll stick with my British roots and rail and hope for the completed Rollman one day. Right. Well, if you can actually wait, then I would just pick up the deluxe edition in next year's spring sale or something with 70% off. That is actually a real treat. So, counting down to 50 for this bend here. And CD Raider says, sometimes I think I'll try Train Sim World 2 again. How much the game has changed. If I remember correctly, there wasn't even a keyboard shortcut to open doors back then. I think there was, at least when I came into the game in Train Sim World 2, you could open the doors with Y and U. I can't say for sure. It would have been on the Schnellfahrstrecke Köln-Aachen for me. So, and now I can accelerate to 60. Because on... Yeah, and the Bakerloo line. I'm quite sure there was. But if you just resume it and play it again, you will see like, oh! That wasn't in the game then. How did we do that when it was in the game? So, approaching Morris Plains, if I remember correctly, we will approach and stop there from 60. From 60 I should start at about 220 feet.
The next station stop is Morris Plains. When leaving the train,
With a 15
please
pounds
watch the gap.
reduction. Can see how this puts us into suppression.
This station stop is Morris Plains.
Still trying to figure out how to stop this train nicely and still in place. One day we should make a special video about the manually lapping brakes. And yes, exactly, the CD radar. The interactive map and train spawn is the best feature for me so far. Made the game so much more immersive. Yeah, that is true. And well, graphic-wise, a lot has happened since then. Even the passenger behavior, a lot of people are making fun of it, and it is sometimes funny what the passengers do. But this has improved a lot, and the optics of the passengers. So will we have any? No, we will stop from 60 in Morristown, and then we will be limited to 50. Because then we will climb to the Convent hill. Greetings to new test slapper 79. Thank you so much for appearing on the chat, and greeting to you. And greetings to you. Not only one. And I guess when we're at Morristown, passing a phase gap here, with that section, here's where it starts. This black dot on the triangular white sign indicates that this is where the dead section starts. I don't think that it is simulated though. A rare weekend off, he says. So I have to stop my train, otherwise.
The next station stop is Morristown. When leaving the train, please watch the gap.
A rare weekend off work, so I don't have to settle for a video on demand of the stream. This is so great. And you're investing your rare evening off for taking part in the stream. I'm very honored. Morristown, guys. This is the stop that is the namesake for the whole line. It is a beautiful DLC, and New Test Slapper says this DLC will be my next purchase. So, I overdid it a bit with the brakes.
This station stop is
But now we did it
Morristown.
very exactly on the point, but we are late. And this means we cannot really enjoy the scenery a lot, because we're going into the presentation. New Jersey Transit cab signaling. And now I need to find the presentation, but with my screen everything is totally out of place because of the hiccups in the beginning. So it's the Presentation's still on. Yeah, well, that, for example, is a hiccup. Anyway, you can see it now, I guess. No, it is just white. I can see it. Interesting. Some weird things are happening. New Jersey Transit safety systems. Before we look at the ATC, CSS or CCS system, let's have the overview what safety systems are on the New Jersey Transit trains. Obviously, we have the alerted system. That is the system what fulfills the function of the old deadman button. It checks whether the driver is present and whether the driver is active. If you don't operate controls or push the alert reset button, you will get an indicator most of the time, a lamp in former times, no more likely on the screens. Then an alarm will sound, and if you don't react anyway, you will get a penalty brake, typically a penalty brake that you can release, so that it is not a penalty brake that will necessarily bring you to a standstill. That is the simple vigilance system that we have in more or less the same form on most trains. The system that checks if the engineer is reacting. Here we have the driver, here is the engineer. Very good work, driver. Tiger. We are talking about American drivers, and they are engineers, train engineers. I should get this into my vocabulary properly. So the system that checks if the engineer is reacting to the cab signals is called the continuous cab signaling system, or is the system that copies the wayside signals into the cab and then connect it with a speed control system and a vigilance system on its own, the automatic terrain control. Two things. It checks whether the engineer reacts to a changing aspect, especially a more restrictive aspect than before, by pushing the acknowledge button. And it checks whether the driver is agreeing with the speed that is ordered by the signal aspect in question. If not, you will get an alarm, and if you don't react and put the brakes into suppression fast enough, you will get a penalty brake. Again, it is not a mean penalty brake as that we get from PZB in Germany, for example, that always stops the train and you can release it only after a standstill of the train, but typically a penalty brake that can be released, and then you can take over the train again and go on without having to stop. This is still not a PTC, a positive train control system that complies with the requirements for a positive train control system. For that, we also need a system that enforces line speeds, civil speeds, and for that, New Jersey Transit developed its own variant of the ASES system that is called the ASES or ASES 2 system. Has its own type approval from the FRA. But you also find documents in the PTC safety plans now that talk about ASES systems. It is typically more or less crisscross convertible, and so it does not make a lot of differences in the implementation plan. You can find some differences, but they are not so super important. So this is the system that will be discussed in a next video. We have discussed the ASES system last in the implementation of the Massachusetts Bay Transport Authority in the Boston Wooster DLC in Extenso, and how it works there. And for the New Jersey Transit, we will look at it again. Also manage speeds and acknowledge in case there is something to acknowledge, and put the brakes into suppression. If you're too fast, you will get an alarm, a different one. This is this spacey alarm that we heard before. Not this beep, 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 beep alarm, but this wow, wow, wow alarm. And then you get the penalty brake if you don't react. And New Tesla says they use the mouse cursor instead of keybinds, so I would be almost guaranteed a penalty brake. That's the thing. Sometimes with the keybinds, you are actually really faster, especially when applying the trains fast, and the manual lapping brakes don't help a lot. What is also important that the ASES or ASES system includes a positive train stop system that makes sure that the train stops in front of a red signal. what is necessary to make the whole system comply with the PTC, positive train control requirements. Otherwise, it would not be enough. So better than, for example, the 2000 Hertz magnets that we have in Germany. We want the train to be stopped in front of the red signal. We prevent actually the spat with this system. We don't mitigate the effects by stopping the train as soon as it tries to pass the red signal, but we want to bring it to a stop before, and this system is incorporated in the ASES or AXES system, and gives you specific indications of the kind. So that was the overview. So what is the cab signaling system in the New Jersey Transit implementation? You find it sometimes also only named as continuous cab signaling, sometimes with a / automatic train control. Those two systems are more like put together, so that some people use this word and some people use the other word. Depends on whether you focus on the signaling part or on the enforcement part. It is pulse code cab signaling. We have talked about pulse code cab signaling a lot, especially in the Northeast Corridor, but also on our Dutch DLC, for example. We send electric currents through the rail, and those are coded with pulses, and the number of pulses tell the train what signal aspect is valid for this part of track, and we will see how it works in a minute. And this allows us to ping signal aspects into the train so that the train can display the signal aspect for the driver. So if the driver missed the signal aspect when passing the signal, he can always check what signal aspect is valid at the moment. Sometimes we can even get rid of the wayside signals and just change the cab signal aspect. And if there is a speed limit connected with the cab signal aspect, then we can enforce this with a system on the train that initiates a penalty brake if we are faster than the speed requirement that comes with the cab signal aspect. So this is the machine that we have on our New Jersey Transit locomotives, cab cars, and if there were EMUs, we had them on the EMUs even, not so on the ALP-45DP, the deluxe locomotive that comes with it. It has a different version. We will talk about this at the end of the presentation. So this is what it looks like if the safety systems are cut out. You can see it, the continuous here you have CSS instead of CCS. This is sometimes used also as a cab signaling system instead of continuous or coded cab signals. Could also call it CCSS, but this is I've never seen. But those abbreviations is typically talking about the same system. CCS, CSS, and ATC is the system that we're talking about today. The cab signaling system and the speed enforcement system that comes with it. The speed enforcement system is then on the other side the ASES or AXES system that is put on as an overlay to the CSS system to make the system as a whole fulfill the requirements of the positive train control system. If we turn it on, if we switch it on, then those things will get green. You can see that it also tells you to what type of train the system is coded, because this can have an effect that different speed requirements are connected with one and the same cab signaling aspect. So we are a passenger train here, and both systems are cut in. So how does the thing then work? We have talked about pulse code cab signaling a lot, and often this is our piece of track, and we connect wires with the rails and actually run an electric current down one rail. Then we connect it to the other rail and then back to our machine on the other rail, so that we have a current running through the rails. And here we can have a machine or a detector that measures actually what is happening there if there is a train shortcutting this, and we can send our pulses along this thing just like on an old radio machine. We need to have insulation gaps between the other sections of the track, so that it does not interfere. Typically then impedance bonds connect those two sections, because we need the rails also for closing the circuit for the electricity that runs the trains coming through the overhead catenary, going through the train, going back to the substation through the rails. This is why we need impedance bonds to connect these thingies. But for our purposes of track circuits and the pulse code signals that run in the track circuits, we need to separate them electrically. And then if the train is in the section, the metal wheel sets of the train will shortcut this current, and then at one thing, this machine will detect that there is a train in the section, and this train can sniff, like the Dutch trains do that with a receiver. They can detect what pulse signal is pulsing here in this circuit. And then we can attach different meanings to different pulse numbers. If there is no signal, what translates to a zero pulse, so if we just have the circuit but no pulse on our machine, this will be interpreted by the train as the most restrictive aspect, and this results in a restricting cap aspect. And this will only allow the machine to let the train go with 20, not faster. Restricting speed, we have seen this in the video about the signaling system for New Jersey Transit. The NORAC system that is used by New Jersey Transit is typically 15 in interlockings, 20 out of interlockings max, also on site, but we cannot really control on site with the system here. So we control the maximum speed that a restricting aspect allows, so we will enforce a maximum speed of 20. This is still some leeway in between. It can happen that the engineer actually has to be slower than the 20, but at any rate it can, or he cannot go faster than 20, so this will be enforced at this point. And at the same time, the ADU will give us a red over blank. I always think that we should hear a red over lunar, but we're not getting a red over lunar at this point. We're getting a red over blank for the restricting aspect. Then we pick a frequency that we can easily handle, like 100 Hertz for our pulses. And on the 100 Hertz frequency, we pulse like on an old radio machine pulses with certain numbers. And if this receiver here detects a specific number of pulses, then, like for example, we put it to 75 pulses per minute, then the receiver will initiate an approach aspect. And this is then an aspect that lets us go 30 just when we entered Denville at this point, and it will show us for approach the yellow over blank ADU aspect here. And then we look at the next number of pulses that our machine can pulse. It is 120, and that would be the next step in our speed escalator that the train can allow us to go. Approach limited 45. In some systems the same pulse number here is connected with an aspect that's called approach medium 45. Does not really matter how you call it. It is 45 that is allowed to go, and the train will actually show you an approach limited aspect here, yellow over flashing green. So why 75, 120? The numbers that are chosen here at this point are chosen in a way that even if for some reason there is an echo and doubles the frequencies that are done here or halves them, it cannot be read as a different aspect. So this is why we don't have 150 here, but 120, because 120 is far from any multiple of 75. The next thing will be 180, and that is then connected with a clear aspect, or in the more modern systems, clear 125, because we have other clear aspects connected with them, and that will allow the train go more or less 125, unless, what often is the case, the civil speed limit, the track limit is lower. Without the ASES system, we couldn't control a lower system, but we can at least control whatever the maximum speed. Typically, our train would be limited to 79 at this point, so this can be hardwired so that we cannot go faster without a PTC system than 79, but the aspect would allow just the maximum authorized speed at this point, and this obviously gives us a high green, a green over blank aspect on the ADU. And this is the classic old 4-aspect cab signaling system that is on some parts of this route actually in action. You will see you don't get any different aspects than a high green, an approach limited, a yellow approach, or a red restricting, and you can do a lot with those 4 aspects, especially if you don't have so super high speed limits. If the highest authorized speed that you have is around the 50, 60, 70 variety, then you're quite good with your steps of 20, 30, 45, and then clear more or less. But if you're running faster, as Amtrak is doing this on the northeast corridor, you want more aspects to fill the gap between the 45 and whatever comes there, even up to 150 miles per hour. So the whole system needed to be enlarged, and this is done by sending a second frequency around the same circuit here. So not just take more numbers, because at some time the receiver cannot count the number of pulses anymore because it is getting so fast. So put a second overlay on it, a second frequency, and then we can double. If we actually have the 75 pulses per minute signal on both the 100 Hertz and the 250 at the same time, then we get a new aspect, and that would be an approach medium 30 signal. That again limits us to 30, like on the approach, so nothing gained a lot, but it can give us a different aspect on the aspect display unit, a red over non-flashing green, what is the approach medium. It does not have the implication that the next signal is expected to be red, but the next signal is expected to let us go with 30 at this point. Well, so this one is not used from what I have seen on the New Jersey Transit owned route part in our TLC here. Maybe you can encounter it on the part of the Northeast Corridor around the Secaucus area, or on your way to New York Penn or back again. So I have not really checked if you get it here, but it is possible that you encounter it there, because in the 9-aspect system, this is defined as that. The 120 signal aspect would then be something in between the 45 and the 125, or whatever is the clear aspect here. Cap speed 80. Cap speed, what is a different idea of having the Wayside signal showing an aspect that actually refers you to what your cap speed machine is showing you, and a typical speed of that would be 80. So one of those aspects is connected with cap speed 80 at the 120 for both frequencies connected. Lets you go 80 and will give you a flashing green aspect on the ADU, as typical for the cap speed signal aspect on the Wayside signals in the NORAC universe and the NORAC signaling system. You will not see this aspect on the New Jersey Transit owned parts of this DLC. So as soon as you're going down Kearny Junction and towards Dover, you will get a steady green instead. So just as New Jersey Transit is not really using the cap speed aspect on the Wayside signaling, it will not appear on your cap signaling machine for the same reasons. But it is in the system and could be done. And if you go to Secaucus, for example, we will see that at the end of our service most probably, then you will see this flashing green aspect on your ALP-46 machine. Doubled 180 would then be a very fast aspect, clear 150 that you can see on the Accela, for example, or the ACS 64 locomotive when you run from Providence to Boston. That would even exceed what our speedometer here can show. So it is clear that this aspect is not used on the locomotive here from New Jersey Transit. It would obviously result in a high green aspect on the ADU and a 150 speed limit. And then to even more enlarge the range of aspects that can be shown with this system, we have an additional number of pulses, the 270. If it is only on the 100 Hz, it translates into a cap speed 60, limits us to 60, again flashing green on the ADU, not used in the New Jersey Transit universe. From what I can see, obviously on the Northeast Corridor part around Secaucus, you can get different speed limits with the flashing green, but whether they actually come from a speed aspect of that kind or whether they are connected with the ASES or AXIS system at this point, I cannot really tell you. The 270 and 270 would result in a clear 100. That allows you 100 and at the same time gives you a high green again. So the 9 aspect system ranges from restricting to different 30 limits and the 45 approach limited 45, a very important aspect, and then the more refined aspects that you don't see that much, at least on the Morristown Line on the New Jersey Transit locomotives, except for the clear 151 that allows you to go maximum speed. Cap speed 60, cap speed 80, clear 100, clear 110, clear 150. If you want to see those aspects in action, you would have to use the Accela or the ACS 64. A new test lab says I will be on the Northeast Corridor next month, Boston South to New York Penn. Now that is great. That is great. You have our envy. So what can we do with this system, our cap signaling system with the speed enforcement? We can do train separation. That means we can rule traffic. If a train is in front, we can slow down the train that is coming after. We can do routing. We will see how this is done. What we can't really do, or only in a limited way, is permanent speed restrictions. This is what we got the ASES or AXIS system then for. And the same goes for temporary speed restrictions that are now in the game in Transcend World 6, since Transcend World 6. And a positive train stop we cannot do with this system either, because for that we will have to send a signal to the train in front of the red signal that really slows it down. But we can already do a lot without AXIS and ASES systems in terms of copying the cap, the wayside signals into the cap and then enforcing the speed restrictions that come with it. So, but if you think back of what we did the week not the week before, but a couple of weeks before, when we talked about the signaling system, the NORAC signals that are used by New Jersey Transit, then you can see at the same time that there are way more wayside signaling aspects than the 9 aspects that we just talked about, or especially the 4 aspects that are used by New Jersey Transit in the cap signaling system itself. That means that we need to know how to translate those wayside signals into the cap signaling system, and the cap signaling system aspects that can actually be shown on our train. And for that, in the NORAC rules, you find a table that tells you what wayside signal aspect can be translated into what cap signaling aspect. And if you do that, you will see that it is actually not so difficult. For the high green, that allows you to go maximum authorized speed, that can be 50, that can be 150. It is obviously the simple non-flashing steady green. For the cap speed, we have talked about this, what is typically in the range between 60 and 80, we have the flashing green. And then our important aspect, as I said, so yellow over flashing green, the approach limited, is connected with a speed limit of 45. And for what aspects this is now used is mainly determined what speed the system allows the train to be at a signal of that kind. And then you will see that for the limited, clear, and for example for the approach, for the advanced approach signal, it is all connected with a speed that you should aim for of 45 in this connection with the advanced approach, or be at through the interlockings in case of the limited clear. And the same goes more or less for the approach slow, for the approach medium, and obviously at the same time for the approach limited signals. So those signals, from what I have seen and to my from what I've seen, I think this one is a bit of an interesting thing, because you could also argue that you should connect this with an approach that limits you to 30, because you have to go down to medium speed at this point as well. But from what I've seen in the table, this should also be an approach limited. The next part of group of signals will be connected with the approach limit that gives you a limit to 30 on the machine, and that is the medium clear in this context, or also every approach signal except for the slow approach signal that will be more restricting at this point. This will be probably connected with a 31. There are some signals where you can actually argue what it makes sense to connect them with, like for example here the approach slow signal. You could also argue this should be connected with the yellow one, because it is actually limiting or telling you to slow down to medium speed at this point. And here at the same time, here the rule says sometimes this aspect here should be connected with an approach medium, not with an approach limited signal, and limit you to 30. Well, here it is connected with, from what I've seen, with the approach 30, and everything that is telling you to go slow speed or restricting, or if you happen to pass a red signal, for example, you will get from the ATC system a red over blank aspect, limiting you to 20, because the 20 is the highest speed that is thinkably possible if you have good side, are out of interlockings and running under restricted speed. So it does not differentiate between 15 and 20, but limits you to 20 at this point. So you can see it is not actually a coincidence that those signals here can be more or less grouped like the layers in an onion, and you can debate about the actual margins and how you want to build your system. But this is it. The red over red aspect for the stop signal when approaching a stop signal is also in your train, and you will encounter this when you hit the positive train stop system. But this is not a cap signaling aspect, but this comes with the ASES or AXIS system. This is why it does not actually belong to the CSS, CCS, ATC system. Yeah, this is what you need to know, how wayside signals and the different aspects in the wayside signals translates to cap signaling aspects. Typically, the connecting part is the speed that the signal allows you to go or orders you to go to. How is this then implemented, and how does it work in the real world? How do we do train separation? You know, this train is running its way with a high green, so it is allowed to go 79, let's say, and then 3 blocks before that train there is another train. So we need to separate those trains so that those trains don't run into each other. How does it work? In a absolute block system, we would have a red signal here protecting this train. In a permissive block signaling system, what we have typically on the northeast corridor and in the busy areas here, we would be permissive and only have a restricting signal here, so that we have to go on site when entering the same block. Multiple occupancy, permissive signals to get more traffic on the same part of the track. That would result in a signal here, approach limited, before we go to the restricting signal, and here in between we have a code changing point so that we can fill in the approach signal that is not on the wayside signals here. And this happens on our machine, so our signals deteriorate from the high green at this point to the approach limited signal that is connected with the approach medium at this point here, limiting us to 45, and we will get, as soon as the aspect drops, a beep 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 alarm, and then we need to acknowledge. This is where we have to hit the acknowledge button, that we tell the train as engineer that we have realized that our signal, our cap signaling aspect got more restrictive, and that we will take action to comply with it. So this we have to acknowledge. If we are faster, we have to slow down, put the brakes into suppression. If we are already at that speed, then all is good. We only have to acknowledge. We get a penalty brake for two situations. Either if we fail to acknowledge within 6 to 8 seconds, or we're running 6 to 8 seconds over the new limit without putting our brakes into suppression. And when do we reach suppression with our brakes? Typically when we have at least 15 pounds reduction. Our pressure in the brake pipe is at 110 for passenger trains typically, and if we reduce it by 15, then we end up by 95 psi, and if we are at 95 or slightly below, then typically this yellow suppression indicator underneath our speed clock will light up, and then we know we are safe. We won't get a penalty brake, the train will just get slower, and as soon as we are below the limit that is connected with our more restricting cap signal aspect, then we can release the brakes again, but don't release them before we are below the low limit. Otherwise we will get the alarm again, and we will have to start it again, and we will lose more and more speed. At this code changing point, as I already said, the cap signal aspect will deteriorate one more. It will get more restricting from the approach limited 45. It will go to approach connected with 30, and then at this point we will, in correspondence with the wayside signal, get the restricting aspect limiting us to 20, and we have to go on site. The system obviously does not check if we go on site at this point, but it will check whether we're going 20 or faster. So this is how the cap signal aspects will make sure that the trains can be separated. And this also leads to the fact that the cap signal aspects jump from one up and down again, because this train is leaving the section, and that means we have one block in between. That means our cap signal aspects upgrades from whatever restricting to approach, and as soon as we go into the next block, then we are again closer to the train in front of, and then it will get more restricting from approach to restricting again, for example. So that sometimes those aspects can flip around when we're chasing a second train, and if we try to always get our speed to agree with it, then we can get crazy. So maybe just let the train roll a bit and not always accelerate when we get a better aspect. How does it work for routing? Quite simple actually. We're running with our maximum authorized speed, and at some point we are supposed to diverge into a different track, and let's say those switches here have a limit of 30 miles per hour that we have to stay under if we are diverging, and for that we would typically get like a medium clear on the wayside signal here telling us 30 now, medium speed 30, and as soon as we are through the interlockings we can accelerate again. And how can we enforce this with our cab signaling system? Well, we want to have an aspect that limits us to the 30, and that is the approach aspect, yellow over blank 30, limiting us here in this aspect, and this will be, well, prepared by giving us a 45 aspect with the approach limited at this point. So when we're going into this section, our signaling aspects will get more restricting. We have to acknowledge, we have to slow down, and then even though there is no red signal on the other end, we will have a yellow signal here, an approach signal that binds us to the 30, and when we are through, then we will get into the next track circuit, and then we will get a high green again, and we are back to maximum authorized speed. So even though we get an approach aspect, there is not really a red signal involved. So this we can make sure and enforce the speed on the switches when diverting for the routing. And then we will typically get a beep for the upgrade of the cab signal aspect to tell us. Can we do, as I said, also permanent speed restrictions? We can do it in a way. Well, if the permanent speed restrictions like the track limit is one of our steps that we can actually replicate with the cab signaling system, like 20 or 30 or 45, then it's all good, then it is easy. But what do we do if, for example, we have a limit of 35 in this sector here? That would typically be announced by a sign of that kind, black numeral on yellow ground, and then in a certain distance we will actually hit this speed limit of 35. Now we do not have a cab signal aspect that limit us to 35. So what can we do? We could do the one that is closest, the 30, but that would be annoying. Then we would only well go 30 through this section like we did in the Denville curve. But then we cannot make use of the slightly higher limit of 35 here. So what would we do? We would limit the train signaling wise to the next higher aspect, and that is the approach limited 45 at this point. And if the and when the limit is over, we go back to a high green. So the train coming here would be maximum authorized speed, getting an approach limited at this point so that it can prepare and slow down, knowing that there is a limit of 35, and then being held to 45 until it has passed this limit, and then go back to a high green. So it cannot really enforce the 35, but it can enforce a 45, what is better than the train running this part of the track with 90 or 70 or whatever much higher speeds. And this is actually done on this part of the track that we're traveling on later on this one junction where we have a 35 limit, and then we will get approach limited signals to enforce a 45 speed. This is from the days before we got the ASES and the AXES system that can obviously enforce the 35 perfectly, and we will see that it can do that when we get there in our service. But at any rate, it is still working like this from the days before we had the AXES and ASES system to provide at least some protection for the trains not going faster than 45 in those situations. So in a way we can enforce permanent speed restrictions, but only in a limited way. Another word that I want to drop at this point, we have so far always assumed that we are connecting our cab signaling aspects with our track circuits. The track circuits with the pulse codes running in them, and via the pulse codes we tell the train the aspect. Now let's look at a different situation. Here is a red signal, here we have to stop, and this is the second but last signal showing us approach. Approach, stop, prepare for the next signal being red. We want the train to have decreasing aspects, like getting the approach signal here obviously, and then getting a restricting cab signal aspect here when it is getting closer to the red signal. Let's say we don't use an advanced approach at this point coming from maximum authorized speed. Obviously here in this section it will get the approach aspect, and then in the next track circuit it will get the restricting aspect, and then we are at 20, and then we can stop in front of the red signal easily. But what, for whatever reasons, we have only one track circuit here between the approach signal and the stop signal. Not two track circuits, but only one. How can we still change the cab signal aspect here? And for that we could use a second machine that more or less runs a second circuit on the track. We cannot use the same electric circuit in the rails because it is already used by this long track circuit, but we can use a so-called audio frequency overlay, an AFO. What is, and I know that because I have seen that in Cactus Juice's video, is used very often in this DLC on the Morristown line by New Jersey Transit, and you can actually use it as an overlay. You put a wiring here that allows you to send an audio signal along this circuit, and as soon as the train is disturbing this audio signal and detuning it, then this machine will recognize this and will send a signal to the machine that controls the pulses in the track circuit to switch the codes from approach to restricting. In what situations this makes sense to use instead of different track circuits, if it is a thing that can be retrofitted more easily than cutting your track circuits into two and having two of them, is a thing that I cannot really tell you, but this is a way of signaling that you can encounter a lot, and it can also use for different things. This is the way of using it that Cactus Juice introduced in his video. And we have not encountered audio frequency track circuits a lot. Now that we have it in the route, I wanted to introduce you to that. Also can be used for door control with platforms that are too short and stuff like this. It is another way of train detection in a circuit, in a part of the track, in a track section. We're getting closer to the end of this presentation. Let's have another look at our speed display unit when it comes to being too fast. Actually, let's say we are in a track circuit that is giving us approach cab signal aspect limiting us to 30, and we are going 42, obviously too fast. Then we will have this red button under our speed clock lighting up, telling us that we are in overspeed condition, that we are actually going much too fast, and at the same time we will have this ray of light in red telling us that this is the gap between the authorized speed and the actual speed that we have to slow down. And then we have to get our brakes into suppression, and as soon as we achieve that, then the suppression indicator will light up at this point. If we don't achieve that, then it will typically happen that we get an overspeed penalty. That means the train will apply a penalty brake and will slow us down. This will typically result that the suppression indicator will light up because the train will put the penalty brake in a way that we get our suppression now, and then the speed will fall. And as soon as we are below the speed that we are supposed to travel at, then the red parts on the speed clock will extinguish. The overspeed penalty indicator will extinguish because the train is handing back the control to the engineer. And at some point, obviously, also the suppression indicator will extinguish, and then we are back at the speed that we want to be. So this is actually quite handy, and we are not slowed down to a stop and have to recover and go again and all those difficult things. There is a bug though in the game from what I have seen, I said that we will get this red dot underneath our speed if we are in overspeed condition, and it will extinguish as soon as the speed drops below the limit. That works in the game. What does not work is if in this situation here, for some reason, the authorized speed increases below our actual speed, because we are running into a different track circuit or something happens that makes the authorized speed to jump. So if actually the authorized speeds overtakes our actual speed, then this red button will be on, even though we are now traveling below the authorized speed again. So this needs to be looked into, I think. But don't get confused. Another look at this machine here, actually interesting. This is what we have in the game. I tried to find out where those machines are described in the PTC documents that New Jersey Transit filed with the FRA to show how they want to comply with the PTC requirements. In 2020 they submitted something that looked like this, and if you compare it, then you can see that the plan of 2012 actually encompassed two different speeds that were supposed to be shown. This does not happen anymore. The one that comes from the ASES access system and the other one that comes from the cab signaling and enforcement system. We don't have that anymore. We only have it in the circle of light in one authorized speed. We cannot, from the machine that we have in the game at least, we can actually not see whether it comes from the cab signaling or whether it comes from the ASES access system. That is a bit confusing. It is, in my opinion, less clear than it is in the MBTA implementation, for example, in Boston Worcester. Yeah, but those two speed indications, obviously that was deemed too confusing and they lost that. What they had at this time planned is a so-called bar of light that shows you how far you are away from the speed enforcement target, from the speed limit change. And this is obviously something that we know from LZB, that we know from ETCS, not horizontally but vertically next to our speed clock, and that was actually planned to put it into the human machine interface, but it obviously somehow did not make it, at least not in the version that we have in the game. And then the ring of light was planned originally like those LEDs in a double row that should show authorized speed, actual speed, and target speed. This reminds me totally of the British automatic train control system that was used on the by the Great Western Railway on some parts of the line, with this double line of LEDs. Yeah, if you look in the implementation plan, the PTC, not development plan, but the implementation plan of December 2020, this thing has been revised in the planning process, and it looks even more than the machine that we actually have in the game now. Those different speeds from the speed enforcement system and the cab signaling system, it fell off, so it got out of the machine. It was no longer pursued. It still had the bar of light to show the distance to the next switch. What did not make it in the version that we have in the game. Also, those keypads did not make it into the game, unlike the F1 to F5 buttons that we still have here, the big acknowledge button, the switch for switching between cab signaling system and non-cab signaling system here. Yeah, and what is interesting here, the circle of light looks more like the one that we see in our game, but it has this extended yellow part of this circle of light. What makes me think that this actually was intended to show the three speeds. Actual speed, obviously here at the end of the red segment. Authorized speed at the moment here on the left end of the red segment and the right end of the green segment, declining when you're getting closer to the target, and this yellow part telling you how much speed you have to lose until you get to the target speed. That would be here then, where you are aiming for 45, slowing down. This does not really happen in the game like this. In the game you always have this ray of light with this little bit of yellow end here that seems to show like the margin of 3 kilometers before you're actually getting across the warning curve for the ASES or AXIS system, before the system intervenes. But it does not show you, for example, if you're traveling with 60 and then you're approaching a limit to 35, then you can see how this circle of light decreases, showing you a falling authorized speed, but it does not show you with this yellow segment how far you actually have to slow down to your target speed. This obviously reminds me of the ETCS signaling, cab signaling system, where you have your current speed and then the yellow part on your speed clock telling you, in accordance to the brake curve, how you have to slow down and where you have to end up finally. If there is something that is wrong with the implementation in the game, or whether this is something that did not make it from this planning state into the actual implementation here, I cannot really tell you. For me, it is actually interesting to look at the different versions in the planning phase here and what actually go in the game. And if someone actually knows how this thing is supposed to work in real life, that would be really, really interesting to know. This little bit here is the indicator that shows you that we have a working radio connections that flashes between gray and purple, and then we know that we have a working radio connection. Last thing, our deluxe locomotive, the ALP-45 dual power, works with the same cab signaling system, but it uses a different speed display unit, not the one developed by New Jersey Transit, but for some reason, and I don't know why, it is using the one that we know already from the Massachusetts Bay Transport Authority in the Boston Providence and Boston Worcester DLCs. Here we don't have a circle of light. Here we have the balloons around our speed clock. And if we are in ATC mode, then the same pulses that we have already seen in some of the slides before are represented by the balloons that are lit up around the speed clock. So that restriction with 20 will look like this, and then the approach one will look like this. Instead of a yellow light connected with 30, we have this balloon with the 30 here. The approach limited 45, or here called approach medium 45, will light up this balloon. The clear 125 will end up in a maximum authorized speed typically, and the other ones would end up in the 30, different than the approach indication. The cap speed 80, what is not used here, oh yeah, here it is actually used. At the same time, the 150, we have no balloon because the machines don't go that fast. And for the other two, the cap speed 60 and the cap speed 100, what is here a cap speed 90 in this machine. Yeah, that is the ALP-45 DP. What is the newer locomotive compared to the ALP-46? Why it is using this aspect display unit or speed display unit now instead of the circle of light version that was developed by New Jersey Transit on its own? I don't know. If anyone knows that, let me know. Would be really interesting to know. And then, yeah, you have the different lights that can be shown here. For perm sub will be the equivalent of suppression. And that's it. Long presentation, interesting topic anyway. This time I cut it into 2 AXIS and ASES system. What is obviously necessary to understand the system in its full will follow in a different video. Okay. Then I can actually go back to train driving. AJ, oh, I'm going to bed. It seems to run so far. Nice presentation. Thank you so much, AJ, for taking care of me. And we will see. It will be a long night a bit. Let's see how long my phone will actually give me enough power to stay up to date with the chat. We still have a bit to drive. Leaving Morristown. Look at this shot. It is so beautiful looking down the road here. Going up the hill to Convent Station. That means we are 50, 60, 70 light speed and the station, and then when going down on the other end it will drop to 60, 50 before we get to Madison, I think is the station at the other side of the hill. Civil speed limit increased from 50 to 60. And as you can see all the time, we are running on a clear aspect on the cab signaling system. So the different speed limits that are shown to us at the moment are not coming from the cab signaling system, but from the ASES access system. Excellent work, says New Test Leper. Thank you so much. Very happy that you stayed with me through this longish presentation. We are now ready for you to spread, he says. I will try my best not to. But you never know.
The next station stop is Convent Station. When leaving the train, please watch the gap.
I'm actually coming in a bit fast. We'll see if that works out.
This station stop is Convent Station.
Convent. On the top of the hill. So 70, and then on the downhill run we will have to slow down to 60 and 50 before we stop at Madison. Probably does not make a lot of sense to accelerate to 70. And soon it will decrease from 60 to 50. Here it comes. And now around the bend we can go back to 70. But we have to stop at Madison. So we can't really accelerate that much.
The next station stop is Madison. When leaving the train, please watch the gap.
As soon as I make a 15-pound reduction, we will see the yellow suppression indicator.
This station stop is Madison.
This is Madison. Also a nice place. Make sure that we don't roll backwards. Now we're running to Chatham. And I think we can go 70 until we get to Chatham. And in Chatham we have to slow down, because then we will go climbing up to Summit. Well, unless we get any adverse signals, we can accelerate to 70 here. Let's see if Chatham is welcoming us with adverse signals. If not, then we have to start braking at about 2,600 feet, I guess.
The next station stop is Chatham. When leaving the train, please watch the gap. This station stop
Yes,
is Chatham.
that was spot on.
The next train to stop on track 2 will be the 11:23.
To celebrate that, we can have the bell running to annoy the passengers for the whole stop.
Orange, Brick Church, Newark Broad Street, Secaucus, and Penn Station, New York. Please stand back from the yellow line. Watch the gap between the train and the platform when boarding.
Now we have a go via location when running up the hill towards summit. $55 at the moment, but it will drop to 50. But most probably we will get upwards signals anyway when we're approaching summit. And new Tesla says it would be nice to have the same shade of green for both the alert and the ring of light. Here on the ADU and the ring of light, you mean? I guess this is a bit difficult because this is actually like a lamp behind. And this is a computer display, but you're right. It would be nice. I can see that, how this disturbs the harmony of the picture a bit. Ring of light, you mean the sun? This is the ring of light. The New Jersey Transit ring of light. And it lights, lights, lights. Like a ring of light. Like a ring of light. Yeah. So, Did I not say I expected adverse signals at any point in time here? We're toiling uphill. And here we are. Approach signal all of a sudden out of the blue. Now it will be hard put not to stall the train, I'm afraid. Well, let's see what happens. And arrow 3 one of the few arrow 3 services that actually go from Summit towards Dover, or almost. Most of the arrow 3 services in the game are between Summit and Hoboken. So, this is what I said. What I said is the bug. We got a drop in the signal aspect from approach to limited for a very short time. This is why we got the red bubble on for overspeed. And before I could even react, the aspect upgraded to a high green again, allowing us 50 what is line speed. And because now the authorized speed jumped over our actual speed, we are no longer in an overspeed condition, so we don't have an alarm anymore.
When leaving the train,
But this red dot is still active, and this, I think, is wrong. And the only way of getting rid of this red dot is actually to go beyond the authorized speed and then fall beyond the authorized speed again. Otherwise, we will be running around with this red dot all the time. But first, let's stop at Summit, where we have a limit of 45. And because of those adverse signals, we are actually late.
this station stop is Summit.
Summit. Always sounds to me like Wallace and Summit. So now our red overspeed button is still lit, but I will show you on the way down before we stop at Short Hills. Wieners also call their old U-Bahn units the Arrow, or more precisely Silberpfeil. Do they do that? Silberpfeil is actually a name that is used a lot. Like the old Mercedes racing cars, Silberpfeil. what translates to silver arrow. So, now let me show how I can get rid of this red button. By going beyond the 45. And falling below it again. No, doesn't work. Does not work. I thought I could get rid of it by doing this. Rail fanning is live right now. So are we. Thanks for the invite. So, stop at Short Hills.
The next station stop is Short Hills. When leaving the train, please watch the gap.
Will do. But we're not leaving the train.
This station stop is Short Hills.
Only a short stop at Short Hills. And we also have to stop at Millburn. Where is the next station? Don't think there is a limit change before we get to Millburn.
The next station stop is Millburn. When leaving the train, please watch the gap.
Trying to catch up the speed that we lost at Summit. Did you see how this guy walked against the lamppost? Maplewood is the next stop. We're really stopping at every possibility. Actually, the limits should increase until we get to Maplewood. We're still in the 50. Now it increased to 60. And now it increased to 70. But not for long. At least not for us, because we have to prepare for the stop already.
The next station stop is Maplewood. When leaving the train, please watch the gap.
Will that work? We're actually a bit fast. Nah, that works.
This station stop is Maplewood.
We're almost back on timetable. And we're stopping at South Orange. So far we are actually really stopping at every possibility. We're on the rightmost track. That is the one that is signaled properly only in this direction. You could travel on it in the opposite direction, but then you would always have restricting cab signals. A phase gap, that means we have to set our throttle to 0, even though it is not. Simulated in the game. Now that we are almost back on the timetable, I don't want to lose any more speed. But I cannot accelerate to 70 because we have to prepare for the stop.
The next station stop is South Orange. When leaving the train, please watch the gap. This station stop is South Orange.
Okay, now the next stop is at Orange. That means we're not stopping at the next two stations. I think they are Mountain and Highland Avenue. And there will be a drop to 60 just past Highland Avenue station. At the end of the straight here. This is Mountain. Already counting down for Orange. But if I'm not totally mistaken, then we have to pass Highland Avenue first before we get to Orange. Yeah. Highland Avenue, and now the drop to 60. Anticipated. And now approaching Orange.
The next station stop is Orange. When leaving the train, please watch the gap.
Now that was a bit much on the brakes. We do that again. £25 instead of Monsieur. This yellow band is not a path of safety. Unlike in the Birmingham Crew DLC.
This station stop is Orange.
See, the radar also had an arrow in the PCB on the Vectron today, he says. The 1000 Hz icon was still active and it said that it was monitoring the speed 1 kilometer, but it behaved normally as if nothing was lit. It was fixed after another 1000 Hz acknowledged. Interesting. As I drive my own trains on various routes for which the timetable is not prepared, I quite often see various errors and faulty signals. Yeah, I'm afraid this is quite revealing then. So, orange. Very nice. Really beautiful. And we made it back into the timetable. For example, I saw a warning about a red light, but with the information that there would be a speed limit of 80. Oh. That is obviously safety critical. We stop at Brick Church, where is the next station. And the last one before we go across the bridge. Unfortunately, I won't make it to the 60 that are allowed here.
Brick Church. When leaving the train, please watch the gap. This station stop is Brick Church.
Brick Church. Probably VR0 with a yellow 8. Is that so? Oh, that is again the paradoxical signaling that we talked about on the Discord the other day, but a VR0 with a yellow 8 is, in my opinion, really paradoxical. That should not happen. So, and now Newark Broad Street is the next stop. But that means we will be definitely getting signals, because we are now going across the bridges first. The yellow 8 would be a ZS 3V. No cars on the road, yeah. Nonsense, is that even USA to see the radar? This is East Orange. We're not stopping at East Orange. It's always a bit confusing, right? Because between South Orange, Orange and East Orange, limited, what is that? Approach limited, that means we have to slow down. There are like 3 stations. Ah, finally we got rid of the yellow button, of the red button. The red overspeed button. And this is the situation that I talked about in the presentation. We are approaching a limit of 35 and getting controlled by approach limited signals, so that even without the ASES access system we had a speed control of at least 45. Signal on top is now an approach medium, but we will still be at an approach limited on the cap aspect. Going through the junction here. Forgot the name of the line that is coming in here. First the civil speed limit ended, then the cap signaling aspect improved, and now we're back at line speed 55. But probably not for long. Here we're getting a high green, but most probably the next signal will already slow us down, because at the beginning of Newark Broad Street Station there is a speed limit of 30, and this is most of the time prepared by...
The next station stop is Newark Broad Street. When leaving the train,
an approach medium signal, as you can see. Approach medium will translate to an approach limited on the cabs. So we're now serving along the brake curve.
This station stop is,
And unfortunately are a bit
Newark Broad Street.
fast in the end. Newark Broad Street. Here the awnings for the tram services. As I have learned from one of the nice comments. But the tram rails are not in the DLC. The tram rail. At least the light rail. Don't know if they call it a tram service. A streetcar. No idea. At any rate, we're getting started at the approach medium on the wayside signals. Respectively, and approach limited. What is a bit counterintuitive, to be honest, because the speed limit is still 30 here and will be on the bridge. So why they are not giving us an approach signal here, controlled with an approach cap signaling aspect, limiting us to 30, is not quite clear. I think in the opposite direction they are doing exactly that. Isn't that nice? So, there is the high green coming in. Let the train run its length and then we can accelerate to 55, at least for a bit. Because we are supposed to branch off towards Secaucus. That means we are bound to see the special signals with the additional lunar light between the two signal heads. That indicates that we are branching off to the left. But at the same time we will probably get an approach limited at this point. But first, we could accelerate to 75, but here is already our approach limited. That slows us down to 45. So we could have anticipated that. So at the next signal we should see the additional lunar light, lunar white light. Same point going through the Go Via location. Here. Limited clear, and here's the lunar white that gives us the information that we are going across the switches. If we had not suspected that. Because here at this hill we have to go underneath and then on top again. This is the track where the trains from Secaucus are coming in. A phase gap in green. Actually we should switch our power supply now. I doubt that this is implemented in the game. And now we can accelerate up here. 12 kilovolts. And now we are actually changing from the new Jersey Transit operated part to the Amtrak operated part, and the signals are now the colorized position light signals of the Amtrak variety, giving us here a cap signal indication, what for a short time resulted in a flashing green, but it was so short that we did not even see it flash. For a very short time we're now in the 90 limit, but most probably it fell to 80, increased to 90 again. That is probably train separation because of a train in front of us leaving the block. We're entering the new block. But now we have to slow down, and this is a situation where it would be actually interesting to see where we are going. 60 for the bridge probably. This is a beautiful part here, isn't it? With our bridge and the road bridge. But now we have to prepare for Secaucus. Maybe we can even accelerate in between. But we're going to... No, we can't. Approach limited on the gaps, limited clear on the wayside signal on top of us. That will limit us to 45.
The next station stop is Secaucus.
And we're going across the switch.
Please watch the gap.
Secaucus station in front of us. So close to the signal here. That shows an limited clear.
This station stop is Secaucus.
Secaucus. Great station. With a lot of floors, and you can just pass through with your camera. But not underneath, only up. Frank R. Lautenberg, Secaucus Junction rail station. Does not only have this level, but also that level. So it's actually a train track crossing without the possibility of switching from one to the other, at least for the trains. The passengers can do that, obviously.
Trenton is expected to arrive on track B in approximately 2 minutes.
A cellar coming in. And running through. And we're doing our last leg. Secaucus to the tunnels and then through the Hudson Tunnel to New York Penn. Limited clear, 45 across the switches. And then we have a lot of time to get to New York Penn. Now you can see a flashing green aspect. So our machine can show a cap speed aspect here. But only because we are on Amtrak signaled territory here. Cap speed aspect on the Wayside signal. High green increased to 90 shortly because we passed onto this fast track, but already slowing down to wherever it is, 75. Before we get to the tunnel, and in the tunnel it will be 60. So our joy of getting to go faster than 60 will be short-lived, because here is already the entrance to the Hudson Tunnel, and we will see the circle of light shrink. And into the abyss. Going downhill quite steep here, so we need the dynamic brake not to overshoot. At the apex of the tunnel we will pass a special signal of the Y-shaped variety that we find at New York Penn, but with additional lamps that even has, if I can see that properly, a C indicator. Or maybe this is just a number, I'm not sure. I think I've seen the letter C. So maybe this can show a C indicator in case your cap signals fail. But for the moment we're still going downhill. Here's a signal is coming in, you can see the red light at the bottom. This is much longer, has a C indicator here. So it would be interesting if this signal can actually give you a C indicator. And now we're getting signals, declining cap signals, most probably. Approach limited, approach maybe even restricting. So I dodged the approach limited. I did not dodge the approach, unfortunately. Should have done a bit more. But this results in us being really slow. What hurts because we are actually climbing uphill really heavily here. Not getting a restricting at the moment. Now we got it. And as soon as we are entering New York Penn, we will have to slow down to 15. This is why the first signal here is not of this Y-shaped variety, but it is a classic three-headed signal with red over green, showing us a slow clear and limiting us to 15.
The next station stop is New York Penn Station. When leaving the train, please watch the gap.
It's maybe the only signal here at New York Penn that is not of the Y-shape variety. Don't know if there is a story aligned with that, but this is probably so that nobody mistakes it for a high green signal that allows a faster speed than 15. Because technically those Y-shaped signals are clear signals, high greens, that allow us to go maximum authorized speed, but the maximum authorized speed is 15. So for whatever reason, I can actually know why. Our speed indication improved from 15 to 20. This is because we don't have any ASES or access information anymore. As long as we had this information, we knew that the line speed was 15. Now we don't have this information anymore. So we are only getting the cap speed indicator. Yeah, the cap speed indicator, nonsense. The cap signal, and that is a restricting, and so the system can only control a 20 limit. This is why we have this increase from 15 to 20 in our circle of light. At least as much as I understand what is happening here on this locomotive. Here's our target signal. That red one is where we have to stop. We have all the time in the world to get there. And make sure that we don't spat in the end. And we don't. We stop at 5 feet.
New York Penn Station.
Exactly where we're supposed to be. New York Penn. Here in ACS 64, American City Sprinter with those beautiful stainless steel cars. And that's it. That's the service. That was the stream about the cap signaling in New Jersey Transit on the Morristown Line. Guys, thank you so much for bearing with me all the time. It was a long thing. In the beginning, we had trouble with the internet outages, and I hope it worked now and we got through it after all. And I hope Vodafone will actually fix that stuff and the construction work will come to an end and we can have reliable internet again. Thank you so much for bearing with me. I wish you the best of weeks. Take care. Be nice to each other. And see you soon. Bye bye.